All right, looking at section 10.7 day 1, I'm going to do 3 problems with you. We'll take a look at plotting a polar point and then finding 3 additional polar representations of that point between negative 2 pi and 2 pi. We'll also convert a point that's in polar form and convert it into rectangular form, and then we'll convert a rectangular point into polar form. Alright, so plot the point 3 comma negative 5 pi over 6. So I'm going to need to have a polar set of axes, which this is the ones that have the circles on them. And so do the best you can to draw circles. Alright, so remember when you're taking a look at this, this is considered to be r and then theta. But you can kind of treat this like a normal x value. If you're looking at the, we call it the pole, if you're looking at the origin, if you will, you're going to move 3 to the right because it's positive 3. So you're going to go 1, 2, 3. That means I'm kind of starting my measurement here. I'm on the 3rd ring basically. And then I'm going to move this angle, negative 5 pi over 6. So that's 150 degrees or negative 150 degrees. That would swing me over to here approximately. And that is where this point is. So this point is 3 comma negative 5 pi over 6. So the x value, if you will, or that's the r value, that tells you what ring to start on. If it was negative 3, you would have started here and then moved negative 5 pi over 6, or I guess that would be up here, wouldn't it? And that just tells you how far the angle is that you're going to move. Alright, so there's the point. Now to find 3 other polar representations. Well, for any polar coordinate, you should be able to have 4 representations. One where you've got 2 positive r values and 2 negative r values. So here's what we did. For the one that we just graphed, this point here, we started here and we moved that way around to get there. Who's to say that we couldn't have started here at 3 and moved this way around? So you just have to ask yourself, how far is that? Notice that that's a positive angle that you're moving. Well, I know that this far would be pi. This is 1/6, so this should be 7 pi over 6. So if I moved 3 to the right and then 7 pi over 6 in a positive direction, that would put me on the same point. That's both ways, starting here going positive or negative. Well, what if I started right here at negative 3? I could move just that direction. That's a positive movement. Starting at negative 3, I could move positive pi over 6. Or if I started at negative 3, I could move a negative direction. I could move pi and then 5 pi over 6, or a negative 11 pi over 6. Negative 11 pi over 6. And there are my 3 other polar representations. So when you see that 3, obviously if I'm just graphing this, yes, I have to start here. But if I wanted to rewrite that a different way, I could start on the 3rd ring, or I could start over here. It's still in the 3rd ring. So hopefully that makes sense. You have a couple in your homework like that today. And then these last 2 are meant to be quicker problems. You just have to remember the four little formulas that we have, and they are this. Either x is equal to r times cosine of theta, y is equal to r times the sine of theta, and those are the 2 that we want to use for this particular one when I want to convert it into rectangular form. And then when you want to convert into polar form, the other 2 formulas you have are r squared is equal to x squared plus y squared, and then the tangent of theta is equal to y over x. So you've got 4 identities, you just have to know which ones to use for what type of problem. Alright, so convert this into rectangular form, meaning I want x's and y's. Well, I have r and I have theta, so this would be a good identity. So x is going to equal r, which is negative 2, times the cosine of 7 pi over 6. So I just need to know what the cosine of 7 pi over 6 is. Well, I know 7 pi over 6, it's over 6, so it's a 30-degree reference angle. That's bigger than 1 pi. I know that that's actually right here. 30-degree reference angle, so I know the x value is square root of 3 over 2. It's negative because of where it is. So I know that this is negative 2 times negative square root of 3 over 2. The 2's cancel, the negatives cancel. My x value should just be square root of 3. And then do the same thing for y. Y is going to equal r, which is negative 2, times the sine of the angle, which is 7 pi over 6. Again, it's a 60-degree reference angle. That means the y value has to be 1/2. I'm in this quadrant, so I know it's a negative 1/2. So this is going to be -2 times -1/2, or it's going to give me +1. And so there it is in rectangular form. All right, now does that make sense in terms of a graph? Well, I'm not going to do the circles, but let's take a look at if I did graph that. Square root of 3, that's somewhere between 1 and 2, so if I put a couple tick marks here, it would be like here, it would be right about here. Think if I actually graph this, if I put 1 ring, 2 rings, if I put a second ring there, I'm saying I'm starting on the second ring and I'm going to the left because it's negative, and then I'm moving positive direction, which is this way. 7 pi over 6. There's 6 pi over 6. 7 pi over 6 is one more, so it actually puts me in the same spot. All right, converting from rectangular form to polar form. Now I'm going to use these identities. So I need to know what r is. So I'm going to say r squared is equal to, or r is equal to, the square root of, since I'm going to take the square root of both sides, and that's going to give me negative square root of 3 squared plus 1 squared, which of course is going to give me the square root of 4, or that's going to give me just 2. And then for the tangent of theta, it's always y over x, so I'm going to say that it's 1 over negative square root of 3. Now realistically, that's something I should recognize on the unit circle. Again, I can divide both of them by 2. It's tangent, so this would be y, this would be x. And so I know that I've got a square root of 3 over 2, 1/2. I know I'm dealing with some sort of 30-degree reference angle. You can easily use your calculator because we're not always going to get ones like this. So type that you can recognize. So type in tangent inverse, negative 1 over square root of 3. And like I always mention in class, you have to be very careful when you use your calculator because your calculator only knows restrictions. So when your calculator tells you that theta is negative 30, you need to look back at these points and ask yourself if that makes sense. Well, negative square root of 3, 1, that puts me over here. That is not 30 degrees, or negative 30 degrees. That is negative 30 degrees. So realistically, I'm looking at 150, or 5 pi over 6. So my polar form equation would be 2, 5 pi over 6. And there it is in polar form. Makes sense, again, if you're graphing it, you go over to the right 2, you would rotate 150 degrees, which is 5 pi over 6, and that puts you kind of in the same spot. All right, that is homework help for 10.7 day 1. Let me know if you need any extra help.